Alright, so we've been talking about different methods of solving this, partly so in case this was set equal to y, we could solve and find x-intercepts, because that's where the y value equals 0. And so we talked about completing the square last time, and so what we want to talk about now is the quadratic, which is really just completing the square in disguise. And so if this is where the quadratic formula comes from, if you have no idea, the quadratic formula didn't come down on a platter from the heavens, and so I'm going to show you where it comes from. If you don't care, you can just fast forward. So the first thing we did was we got rid of, we wanted this first term, the a term, just to be 1. And so that's what I'm going to do first. Now this is going to look ugly because it's only got variables in there, but that's what we have to do when we're going to solve something in the generic form. So I divided by a, everything gets divided by a, 0 divided by a is gone, and I moved the c divided by a to this side. And then what we do is we take half that middle term. So half of b over a, half of a half is a fourth. You double the bottom. And so what I'm going to do is b over 2a, b over ax, I'm going to add b over 2a squared. And I'm going to add that to both sides. So b over 2a squared. So now, what we were going to then was that factored into x plus b over a, b over 2a, and x plus b over 2a. And really it'd probably be helpful if you just looked back at how we did it before. Anyways, this is negative c over a plus b squared over 4a. And what I'm going to do is I'm going to write this as we're used to seeing it, x plus 2a squared. We completed the square over here, so we're going to take the square root of both sides. And here I'm going to flip these two around just because b squared minus c, and actually I'm going to get 4a squared. And so in order to get common denominators, I'm going to multiply this by 4a over 4a. And so I get b squared minus 4ac. That sounds familiar, right? I flip-flop the top two. And then you get 4a squared on the bottom. Take the square root on top, both sides, and you get x plus b over 2a equals square root of b squared minus 4ac all over the square root of 4a squared is 2a. And remember, plus or minus anytime you take the square root of both sides. X equals, subtract this to the other side, negative b over 2a. That is where the vertex is. Plus or minus the square root of b squared minus 4ac all over 2a. And so this is usually how we see it separately. Notice that this is the vertex, and then the x-intercepts are plus or minus some amount left and right of there. We add and subtract. So you're typically used to seeing it negative b plus or minus the square root b squared minus 4ac all over 2a. And so it's really just completing the square with the variables in it. This is something you need to know. Know it well. Know the negatives, the subtractions, plus or minus. Know that all of it is divided by 2a. If you want to think of it as being separate, you can. I talked about how that is the vertex or the axis of symmetry. So let's solve it. This is your a, and actually let's 3x squared plus 2x minus 6 equals 0. So a equals 3, b equals 2, and c equals negative 6. And so x equals a negative b, which is negative 2, plus or minus the square root of 2 squared minus 4 times 3 times negative 6. All over 2a. So 2 times our a, which is 3. So there's negative 2 plus or minus the square root. That is 4 minus 12 times 6, which is 70. 74. I'm just going to double check that if you don't mind. 4 72 plus 4 is 76 over 6. Now 76, you want to double check. Does it have a perfect square? Can I reduce that? And it does, because 76 has a multiple of 4 in it, right? 76 divided by 4, 19. And so I can pull out the 4 and change that to negative 2 plus or minus 2 root 19 over 6. You have to be very careful with this because there's a 2 in both of these, but you don't want to just cancel out one of them. Think of it as factoring out the 2 and leaving negative 1 plus or minus root 19 and then canceling out the 2. You have to cancel out the 2 out of both of them. So negative 1 plus or minus root 19 over 3. So that's what we get. The approximate version of that, this is what we call the exact. If I type this in and I do negative 1 plus the square root of 19 divided by 3, notice how I'm typing in and I'm putting the parentheses around the numerator. So you get 1.11 or negative 1.79. There we have it. Let's try another. So we have negative x squared plus 8x equals 12. You can move the 12 over, or some people really like keeping the x squareds positive. I am one of those people. And so I'm going to move that over. So positive x squared minus 8x plus 12, and plus there's something else I want to show you. So a equals 1. You don't need to write all this down. I'm just doing it because I think it's helpful sometimes. So negative b. Let's take a look. Negative b is a negative 8, so it's a positive 8, and that's the whole reason I really wanted to do it. So we'd have a negative 8. Square root. And then some people always insist on putting the negative here. It doesn't really matter because you're squaring it. Minus 4 times 1 times 12. So we get 8 plus or minus square root of, that's 64, minus 48, and that would leave 6, right? 16. I'm such a dork. 2. Okay. Math is so much harder when you're doing it when you're being filmed, right? Square root of 16 is 4. And so sometimes when you do the quadratic formula, you get 8 plus 4 divided by 2, which is 12 divided by 2, which is 6, and 8 minus 4, I'll do this down here, 8 minus 4 divided by 2, 4 divided by 2 is 2. And so here's what I mean by checking your answers graphically. Because remember, if you set it equal to 0, that's y equals that. And so this is what I mean. X squared minus 8x plus 12. Graph it. And I got a weird window here. I just hit zoom 6. So I have positive 2, positive 6, where it's crossing the x-axis. You can double check that with the 0 feature that we did. Second, calculate, and the 0. We did left bound and right bound. And it crosses at 2. be careful with all the plus or minuses. Be very careful. So let's have some fun with some projectile motion. So one of the greatest applications, quadratics, is projectile motion. All you physics people know this. So if something's thrown or dropped, height at any point in time is determined by a quadratic equation. This is what it looks like. Its height, you have negative 5t. This has to do with gravity. It's half of gravity, and I'm rounding it here just to make it a little easier. Gravity is 9.8 meters per second squared, and it's negative because gravity pulls down relatively. V is your initial velocity, initial speed that you throw it at, and then h null is your initial height. That's all explained right here as well. And we used a similar form when we started it. We just didn't have this middle term because we didn't throw it, we just dropped it. So, throw a baseball with an initial speed of 15. That is your v. Sometimes v sub 0 if you're talking about initial velocity. Leaves your hand at 1.5 meters off the ground. That's your initial height. How long will it take before the ball hits the ground? So, when I read this question, I think, how long will it take? So I'm looking for t when the ball hits the ground when h equals 0. So let's fill in our h equation first. H equals negative 5t squared plus our initial velocity of 15t plus initial height of 1.5. So, how long will it take before the ball hits the ground? Well, when will it be 0? So, h equals 0. I'm going to say 0 equals negative 5t squared plus 15t plus 1.5. And since this is a story problem, I'm just going to do the quadratic formula. Negative 15 plus or minus the square root of b squared minus 4 times negative 5 times 1.5 all over 2 times a, negative 5. So negative 15 plus or minus 15 squared minus 4 times negative 5 times square root of 255 over negative 10, 2 times negative 5. And so we can get two approximate answers. Negative 15 plus the square root of 255. And actually, yeah, that's not very pretty. Negative 15 plus the square root of 255 divided by negative 10. And do the same thing but with the minus. So we get two answers, negative 0.097 and 3.097. Now this is negative time, and I guess I should have said t equals rather than x equals since we're dealing with time. And so we're going to throw this one out because it didn't hit the ball 0.097 seconds ago. It hit the ground 3.1 seconds. And so I guess we should round this up to the nearest hundredth at least. We don't usually deal with thousandths. And when does the ball reach its maximum height? So imagine with me what this looks like graphically. Remember this 1.5 is our initial height. And so 1.5, you throw it, hits the ground. Say this is 3 seconds, or 3.10 seconds. When does it reach its maximum height? We're talking here, maximum height. That's the vertex. In disguise, they didn't say what's the vertex. They asked for it in disguise. So, negative b over 2a. Negative 15 over 2 times negative 5. So 15 over 10. That's 3 over 2. So after 1.5 seconds, it reaches its maximum. Alright, so let's talk discriminant. The discriminant is this b squared minus 4ac. The whole reason we brought up the fact that we had square roots of negatives that we could find now is that sometimes you take and you have the square root of b squared minus 4ac. And this tells you a lot about the kind of graphs you have. So if b squared minus 4ac is greater than 0, that's the square root that you can take if it's positive. Square root of a positive number. That tells you that you have two real solutions, two real numbers. If you take the square root of 0, you're going to have plus or minus 0, so that's really only going to give you one answer. So two real solutions might be a parabola that looks like that. One real solution might be a parabola that comes up and touches, but then is tangent. And then finally, if you get plus or minus the square root of a negative, you get imaginary numbers. You get I out. And so that's when it doesn't even cross. That's when you get imaginary solutions. 0 real. So sometimes they ask how many real solutions, or you could say 2 complex solutions. And we say complex solutions because it's A plus BI. Real and an imaginary number together make the complex numbers. Alright, so let's see what we get. b squared minus 4ac, 10 squared minus 4 times 8 times 2. Well, so right off the bat, I know 4 times 8, 32 times 2 is not going to be more than 100, and so this is going to be positive. So I'm going to get two real solutions. b squared minus 4ac. First, I need to do 3b squared minus 14b. Subtract the 24 over, otherwise it's no good. So you get 14 squared minus 4 times 3 times 24. So you've got 14 squared minus 4 times 3 times 24. That's negative 92. And so that's less than 0. So that gives you two complex solutions. And finally, b squared minus 4ac. You got 2 root 10 squared. So that's 4 times the root 10. So 2 squared is 4, root 10 squared is 10. Minus 4 times 5, your A, times 2, your C. So 40 minus 40. You can imagine that it was equal to 0 because that was the last one left. So that gives you plus or minus the square root of 0, one real solution. So, moral to the story is, you guys are going to try to memorize these. When it's greater, there are 2. When it's less, they're imaginary, and when it's 0, it's 1. Don't try to memorize it. Think. If you add or subtract the square root of a positive, well, you can take the square root of a positive. So there's 2 answers. If it's plus or minus the square root of 0, well, that's only 0. You're not going to add or subtract anything. You're only going to have one answer. And if you take the square root of a negative, you get imaginary numbers. Quadratic formula. One more tool in your chest for solving quadratics. If you can't factor and you don't want to complete the square, just use the quadratic formula.